4, which is completing the square. So in completing the square, you had to potentially, you should have completed the square in Math 2, or maybe where you should have had to solve a quadratic. So this is kind of solving a quadratic. Now, you may not have liked to use completing the square, so you may have chosen to do the quadratic formula or factoring or something like that, but this is the one that works the best for these problems. So there are 7 steps they go through right there. Those notes are already kind of done for you, so that way we can go ahead and answer the question. So A, B, and C just ask us to complete the square without going through and solving it. So completing the square is, if you look at step 3, it is dividing the B term. B is the number in front of X. So you want to divide that number by 2 and then square it. Okay, so in this case, in A, the number in front of X is -1, so it'll be -1 over 2 squared. Okay, so -1 divided by 2 squared, if you don't know what that is, you can put in your calculator, but that should give you 1/4. Anything squared is going to be a positive number. It doesn't matter if you're squaring a negative or if you're squaring a positive, because a negative times a negative is a positive, and a positive times a positive is a positive. So you should always get a positive number. So here, you always take the number in front of X, divide it by 2, and square it. So this would be 20 divided by 2 squared. And then down here, this would be 4 divided by 2 squared. So in B, what's the number that we add at the end? In B, 20 divided by 2 squared. 100, yep. So that would be 100. And then in C, 4 divided by 2 squared is 4. Okay, so all you're doing is, that's just showing you one step of completing the square, but it is one of the more important parts. Step 3 is, that's what they mean by completing the square. It means you're taking the number in front of X, you're dividing it by 2, and you're squaring it. And what happens is, these are perfect squares, what happens is it creates 2 even factors. So basically, 2 numbers that multiply to give you 100 and add to give you 20 are 10 and 10. Right? So it makes it even. So it's like X plus 10 and X plus 10 is what will work to give you that 100. So while we go through these, you can kind of get a visualization of what you're doing. Now, when we get to ones with circles, they have X's and Y's. So it's basically like you're completing the square twice, because you have to complete the square for the circle. So you'll have an X squared and you'll have a Y squared, and it'll ask you to complete the square. So we have to be able to do it with the quadratic first, and then once you completed the square with quadratics, then you can complete the square for a circle. Okay, so we move to the, there's just 4, I think, down here, A, B, C, and D, but they do take a little bit of room because they're multiple problems here. So step 1 is to, and I don't have the steps up above, but step 1 should be to move the number over. So you're going to say X squared plus 4X is equal to 12. So I just added 12 to the right side. And I just want my A and my B on the left side. A would be the number in front of X squared, and B is the number in front of X. So the next step is going to be where I'm going to I want to actually find what that number is that I need to add to both sides. So B over 2 squared. So 4 divided by 2 squared, we already said that earlier, is 4. So that 4, I'm going to add to both sides. So it's going to be X squared plus 4X plus 4 equals 12 plus 4. So if you notice, I'll underline it. I added that number to both sides. Whatever B over 2 squared is, I need to add that to both sides of the equation. Now, on the left side, I'm going to write that as a factor, basically. So you can think of it in two different ways. You can either think of it as what goes in parentheses is this, that was already in parentheses up here, or you can think of it as what two numbers multiply to give you 4 and add to give you 4, that's 2 and 2. So it's just going to be 2. So x plus 2 squared. So sometimes people say, well, where did the 4 go or whatever, but it's there. It's just like you're doing FOIL backwards. So if you did x plus 2 times x plus 2, and you FOILed that, you would get x squared plus 4x plus 4. So you're just like packing it back inside. So you're doing a reverse FOIL. That's what you're doing by factoring it. So x plus 2 squared is equal to 12 plus 4, that's 16. And we want to solve for x, but it's squared, so what do you have to do if it's squared? You got to take the square root to get rid of the squared. So we want to get rid of the squared, so we're going to take the square root of that. So x plus 2 equals, now, anytime you take the square root of a number, it could be the positive or the negative, because in this case, it's going to be plus or minus the square root of 16. So anytime you take the square root of a number, it could be the positive or the negative. So the square root of 16 is 4, but 4 times 4 will give you 16, but also negative 4 times negative 4 will give you 16. So you have to put plus or minus there when you take the square root. So plus or minus 4. And then the last thing you're going to do before you solve it is move the number over. When you move the number over, it goes in front. So you're putting a minus 2. So x equals negative 2 plus or minus 4. And then you want to actually solve that. So negative 2 plus 4 is positive 2. And negative 2 minus 4 is negative 6. So that's completing the square. Now that's doing it for a quadratic. We're going to do it for a circle in just a little bit, which is actually, I think, going to be easier, but we'll see. So those are our two answers. As you do more of these, they should get easier as we go through. So B, x squared minus 12x equals negative 7. So we move the 7 over. That's the first step. Make sure your number's on the right side. Make sure your x squared and your x is on the left side. We're going to say negative 12 divided by 2 squared. What is that going to be? 36. Yeah, 36. So we say x squared minus 12x plus 36 equals negative 7 plus 36. This one doesn't turn out as pretty. Okay, now, in parentheses, we say we're going to put the number that when you multiply it, right, it'll give you 36, and when you add it, it'll give you negative 12, and that's a negative 6 and a negative 6. You can also think of it as it's going to be this, negative 12 divided by 2. However you want to think about it, that's what it is. So x minus 6 squared equals negative 7 plus 36 is 29. Now we have to take the square root of both sides. The only problem here is, obviously, the square root of 29 is not going to come out evenly, so we're going to have to just leave it like it is. So when we take the square root of this side, we get x minus 6. When we take the square root of this side, we get plus or minus the square root of 29. And if you did a square root of 29, it's like 5 point something, but it doesn't come out nicely, so we just leave it there. So lastly, we move the 6 over. So we're going to say plus 6. It goes in front. So the answer is x equals 6 plus or minus the square root of 29. You should remember getting answers like that from Math 2. When you do like the quadratic and it didn't come out evenly and you use the quadratic formula, then you would end your problem with an answer that looks something like that using the quadratic formula. So there's how it works. So if our square root if you can take the square root evenly, then we'll end up getting 2 number answers. If you can't take the square root evenly and it comes out as a decimal, then you'll just leave it like that. final answer. Okay, that's A and B. Let's go to C and D, and then I'll show you one with circles. So most of this is review of quadratics. So C is going to be a nice one for us, and then D we have to do one extra step. So C is going to say x squared plus 2x equals negative 3. We're going to say 2 divided by 1 squared. 2. 2 divided by 2 squared. I was already giving you the answer. 1. Because 2 divided by 2 is 1, and 1 squared is 1. Okay? So that is our number that we're going to add to both sides, which makes this problem pretty easy. So x squared plus 2x plus 1 equals negative 3 plus 1. You might can see what's going to happen over on the right side. On the left side, what do we put in parentheses? X plus 1. Yep, 2 divided by 2 is 1. And on the right side, negative 3 plus 1 is negative 2. Now we want to take the square root of both sides. So we're going to get x plus 1 equals plus or minus the square root of negative 2. What do we do with the square root of negative 2?
You have to do the negative out the square root.
Yep, and it turns into what? Well, the square root will turn into positive. When you take a negative out of the square root, what does that do?
All thing I remember is the truth.
It makes it imaginary.
It makes it's an imaginary number. So if you do the square root of negative 2 in your calculator, it'll say error, non-real answer is what it'll say. It means if it's not a real answer, it means it's a complex solution, what they call imaginary solution. All that means is you can't do the square root of a negative number. We've always talked about that. So you put plus or minus, it turns into an I, and that way you can actually do the square root of 2. So, but the square root of 2 is not going to come out evenly, so we're just going to leave it. So it's plus or minus I squared root of 2. Again, that's a review from math 2. So negative 1 plus or minus I squared root of 2. Again, I think the circle ones are going to be easy because you're not going to have imaginary circles. Okay, so you're not going to get the I when we do circles because your circles have to actually turn out to be circles. If you had an imaginary circle, it wouldn't even be a circle. It would be another thing. Huh?
It would be like a weird shape.
Yeah, I don't know what it would be. It would be, we wouldn't see it. D, the issue with D is to complete the square, you can't have a number in front of x squared. So the issue with D is that you have that number 3 in front of all of them, but they all divide evenly by 3, so that's good. So you take the 3 out, and you have x squared plus 5x minus 7. And at that point, we can act like the 3 is not there anymore, and we can say x squared plus 5x equals a positive 7. And now it's okay, except for the first time we're going to end up with some fractions. So we say 5 divided by 2 squared. You might know what that is? Should be, you would think I was asking you to do something crazy. 5 squared is 25 and 2 squared is 4, so it's 25 over 4, so that's 6.25. So you can either write it as 6.25 or 25 over 4. Typically, they're going to leave it as a fraction. So we're going to add 25 over 4 to both sides. All right, now, what would I put in parentheses here? Oh, what did I put in parentheses here? 2 over 2, 1. 5 over 2. So let's put 5 over 2. Okay? Now, What would 5 over, think about that though. If you're thinking about it, 5 over 2, we could write it a little bit differently, but we'll leave it like this. In this case, it doesn't matter. Equals 7 plus 25 over 4. That's 13.25. And I can make that into a fraction. The fraction should be, you can check me, but I think it's 53 over 4. Yep. So 53 over 4. Now, just because we have fractions, it's still the same thing. So now I'm going to take the square root of both sides. So x plus 5 halves equals plus or minus the square root of 53 over 4. And then I can just move the fraction over. And I would like to show you, I'm going to show you something here. So there is your final answer, which doesn't look really nice. But what you can do is you can go to Desmos, let's see, 3x squared plus 15x minus 21. So let's see if I can get to check my answer on some of these, if it's like that. If I go to the Desmos calculator, y equals 3x squared plus 15x minus 21. If I get my answer there, notice I get a 6.14 and 1.14, right? So I want to know, is that what this is saying down here? So I'll say negative 5 halves plus the square root of 53 over 4. And notice that gives me 1.14. And then I could say negative 5 halves minus the square root of 53 over 4. And notice that gives me negative 6.14. So I've actually checked my work to make sure that my final answer matches the calculator. The steps that we learned for quadratics are still going to apply the same here. Step 1 is move the number over. So I'm going to leave it as x squared minus 2x and y squared minus 4y. It's going to be equal to positive 4. So I've added the 4 to the right side. Okay, now I'm going to have to complete the square twice, is what I have to do here. So I'm going to take numbers that work nicely in this problem. So we're going to take the negative 2 divided by 2 and square it. We're also going to do the same thing with our y, the negative 4 divided by 2 and square it. Okay. So negative 2 divided by 2 squared is 1. And negative 4 divided by 2 squared is 4. Okay, so those are the numbers that you want to add to both sides. Now watch how we do that. We're going to say x squared minus 2x plus 1. I'm going to underline it just so you know I added it. Plus y squared minus 4y plus 4 equals 4. And then you have to add it to the other side too. So I take the b over 2 squared, and I have added that to both sides. So that's the key there. But I had to do it twice. I have to do it for the x's. I have to also do it for the y's. Now, x squared minus 2x plus 1. What would go in parentheses? Yep, negative 2 over 2, which is negative 1. So it's always... One way you can think about it is whatever's in here is what goes in parentheses, or you can think half of this goes in parentheses. But it's usually easier to just say whatever is in parentheses here is what stays in parentheses. So negative 2 over 2 is negative 1. So that's x minus 1 squared. Negative 4 over 2 is negative 2. So that's y minus 2 squared equals 4 plus 1 plus 4 is 9. And now magically we went from that, what looked to be a complicated equation at the beginning, to the equation of a circle, right? So the equation of the circle, they will then ask us potentially, what is the center and what is the radius. And so the center of this circle is opposite. Yep. 1, 2, and the radius is not 9, but what? 3. It's the square root of that. So the center is 1, 2, and the radius is 3. And you have finished by completing the square. Okay, so that is what we're looking for today. So I'm going to give you one more to try. I'm going to let you try this one yourself.
Alright, this is a lot easier.
It is. It's easier than this because you don't have to go and solve it. You just have to find the center and the radius. And so you're actually completing the square, but then you get to stop. Instead of in a quadratic, you complete the square, but then you got to move everything over and take the square root and solve it. Now, you're actually taking the square root to find the radius, but you're not like trying to solve for an answer. So let's take...
I have a question. So if the radius, if let's say it was 10 instead of 3, also 10 instead of 9. When we do it, can we just put a square root of 10?
So if the radius was 10 instead of 9, I'm getting ready to answer your question on this next problem.
That's a new problem.
Yes.
That is the next one.
Yeah, so there you go. So x squared minus 6x plus y squared plus 8y minus 3 is equal to 0. I want you to use the one we just did and give it a try, and then we'll go back and I'll go through it. I'm trying to write it out. But you can know that the minus 6, it's going to be half of that, and the plus 8 is going to be half of that. But what you're doing is, again, negative 6 divided by 2 squared, and that gives you 9. And you're doing 8 divided by 2 squared, that gives you 16. So you're taking the 9 and the 16 and adding it to the 3 that's already over here. So that is how you get 28. And then in parentheses, you're putting half of those, or what's in parentheses. Negative 6 divided by 2 is negative 3, and 8 divided by 2 is positive 4. So now we get that the center of this circle is 3, negative 4. And we get the radius of this circle is the square root of 28. So, which we can just leave like that because it does not, kind of like we did with the quadratics, that doesn't come out evenly. Now, if I had to match it to an actual circle, then I would need to know that the square root of 28 is about 5 something, So I may need to check that if they ask me to match it to a graph. But one of the most common mistakes that I see is people just write 28, or they don't take the square root. Sometimes people take half of this for some reason and say 14. I don't know why, but just different things there. But remember, the square root is the radius, and then if you're taking the radius and putting it into the equation, you always square it. So you can kind of make a shortcut for yourself when you're going through these problems on completing the square. Another thing, if I got that problem on the exam, then I would move the 4 over, and then on Desmos, I would be able to see that these are my 2. You could see your radius. So you would actually know your x's there are 1, so your center's got to be 1, and then the midpoint of 5 and negative 1 is 2. So the center is actually 1, 2, which is what we got, right?
Yeah.
So there's the center. I can make it a point. You don't have to, but whatever.
Oh, I
So there's the center of your circle. And then from there to there, you can see you're just going from 2 to 5. So your radius is 3. And that's what we got for that first one. So you're able to check that. Now on the second one, that's just a way of checking your work. So you know that it's 3 and negative 4. That's what you got. So we check that. And then negative 4, how far is it to that point on the circle? It's 5.29. What's the square root of 28? 5.29. So we know, there's no doubt that I have the correct answer at that point. Especially when you get to if you're on the exam and you're having to go through 9 units and you get a problem like this, instead of taking 10 minutes to complete the square, you're able to just throw the problem up there and check your work as you go through it. Exam, they do ask this sometimes. So completing the square is like 7 parts. They can say, what is b over 2 squared? Or they can say, they can give you a problem. The typical one is they give you a problem that somebody did, all worked out, and they say find the mistake that they made or something like that. And that means that you have to know how to go through and solve it using completing the square to get the answer. So you want to use the formula that we did in order to get that. And they're putting in a